Okay, so now the last proof, we're gonna prove the volume of a sphere. So this is a sphere. Well, clearly it doesn't look like one, but it's a circle, but it's a sphere because it's a sphere. Yeah. And the yellow bit is the cross section. R is the radius, and this is the coordinate points, just for a bit of reference. And Y, as you can see, and X form a triangle with the radius. And Y is just the radius of the cross section of the circle, and X is the distance from the y-axis in which the cross section is placed. And now once again, we write this formula. And now we're going to be integrating with respect to x because the cross section is on the x-axis. So we're going to do this. Now once again, we figure out the area of the cross section, which is just pi times the radius squared. And now what is that? Oh, it's pi y squared. So now, once again, in all the types of proofs from before, we have to write y in terms of x. And this is actually a bit tricky, but there is a way. Well, you just use Pythagoras. So you know this is a right angled triangle because the y-axis and the x-axis intersect at right angles. They're perpendicular. Okay, so r squared, which is the hypotenuse of that triangle, is equal to x squared plus y squared. Now we take this, we rearrange it, so we're solving for y squared. Well, yeah. So y squared is equal to r squared minus x squared. Take the square root of both sides, you get y is equal to plus or minus the square root of r squared minus x squared. We've got this, we input it back in. Ready? Okay, let's go. So we have this is equal to pi times plus or minus the square root of r squared minus x squared, o squared. And now it's a bit of a fuss to simplify this, but not really. I mean, we could have just used this and input it in, but really, we just want to show the steps. We want to follow the method. So, of course, this simplifies to pi times r squared minus x squared because the square roots and the square cancel out. So now we take this equation, well, it is kind of an equation, and we input it all the way back into that. So you ready? Erase time. So now we have this. Okay, so now we've inputted the upper and lower bounds. These are the correct ones. We are going to take the antiderivative. But before we do that, we once again have to take out the constant. So it's going to be pi negative r and r. Then you have r squared minus x squared, then dx. Now we need to find the antiderivative of r squared minus x squared. But before we do that, you need to know something. If you have an integral of a and then dx, that's not a nice looking x, okay. This is equal to a times x, the antiderivative. Because, well, that's just a law. So yeah, you need to know that. And now, of course, we take the r squared and you multiply by an x. Because that is the rule. That's the property of an integral, basically. It's one of the properties. Okay, now the antiderivative of x squared is just 1/3 x cubed. And now we have to draw, well, we have to write the limits, like that. And of course we have the pi in the front, the lonely pi. Then we have to input r into x. And now also a bit of a note you might take, because taking the antiderivative is a bit difficult sometimes. So this is how. If you have like an x squared, right? You just add 1 to the power, so it's x cubed. And then you want to multiply by the reciprocal of that, so 1/3. If you're integrating x cubed, well, you just get 1/4 x to the power of 4. And now, just now I already mentioned, when you have the integral of a dx, this is equal to a times x. So just now when we had r squared minus x squared, and then dx, since we're using x, we just multiply by this thing. If it's y, then this becomes y and this becomes y, okay? So this is r squared x. If it's y, it's r squared y. And if you had something like r cubed minus y to the 4, and then dy, of course, we can use the same principle and you get r cubed y, and you subtract 1/5 of y to the power of 5. And then that is going to be your result. So that is all for today. That's just a bit of a review for antiderivatives. Bye and see you next time.